Hey guys, welcome back to the shop. Today we have a very special project. It is a custom order. It is called a drop blood tuna knife or something like that. Basically, it's for stabbing into tuna fish to bleed them out without destroying any of the delicious tuna meat. So let's get to it. Now, I don't know much about hunting tuna, but I do know that they live in salt water, and I do know that salt water is generally not very easy on carbon steels and things like that. So we're going to use some Magna Cut stainless steel, and we need a blade that's 1.5 inches from the guard to the tip. Now what I'm going to do here is simply forge this forward so that we have a nice continuous, let's put it in the forge. Alright, we've got that forged to where we can get the dagger shape of the blade that we need. Now we need to cut some stock off right here and then forge out the hidden tang portion of this blade. Alright, we have a rough shaped forge in here and plenty of extra material. The blade's going to be a lot shorter than what this looks like here, so we have plenty of stock for a tang. But before we get too crazy on this, we're going to take this to the surface grinder on the KMG TX and make things flat, and then we'll refine the profile quite a bit here. All right, now we can put our profile on here once we put some of this handy dandy layout fluid on here. Let that dry, and we can scribe a very clear representation of what we need to profile out. Little tip, if you need a scribe, this is a 1/8 inch chainsaw file, and I've just ground a sharp point on it, making sure that you don't overheat the steel, but it's quite hard obviously, and for most things it works pretty well. So right now I'm resisting the urge to make this blade longer than it's supposed to be because it's looking like such a cool little fat dagger blade, you know, but this is only supposed to, the blade's only supposed to extend 1.5 inches from the guard. It's designed to penetrate a very specific depth to bleed out a specific artery or whatever on the fish, and it's not supposed to be any longer than that. I'm going to give myself a little bit of extra, of course, to clean up post heat treat and everything like that. So that is actually going to be about the length of this blade on this knife, and the rest of it plenty of material for a handle, and I got to take out all of this. I kind of misjudged kind of where I needed to forge the tang, obviously, so we're going to be wasting a little more material than, well, not that much. All right. All right, we've got our little tuna spear, profiled out, and it's still significantly longer than it's actually supposed to be. I still can't get over how short that's. Anyway, now we need to heat treat this, and that involves wrapping it in some high temperature stainless steel foil so as to protect the steel from the high temperature atmosphere that it's going to be subjected to during this process. This process must be undertaken with gloves or extreme care, because this foil can definitely cut you bad. All right, the next thing is to pop this into the kiln, where it's going to heat up to about 1560 Fahrenheit. It'll hold there for about 15 minutes and then move on to the austenitizing temperature of 2050 degrees for a pretty decent mid-range-ish heat treatment on this MagnaCut steel. And of course, by mid-range, pretty decent heat treat, I mean the best heat treatment for this particular application, because as with many other steels, MagnaCut is one where you can do different things with the heat treat, and it is a stainless steel, but you can make it more or less stainless, more or less tough, more or less abrasion resistant, depending on the type of heat treat that you do. And in this case, it has a lot to do with the fact that it's a high alloy, high carbon steel. Higher austenitizing temperature, more carbon into solution, more of that chromium is combined with the carbon to create carbides. Less of it's available to make the steel more stainless, and also less tough, more carbides, less toughness. But then you can, bring that down a little bit, still have a good amount of carbides for abrasion resistance, but leave enough of that chromium in solution so it's more stainless. Anyway, all that to say is that we're doing a heat treatment that's going to be a good application for this particular tuna knife. Draw blood knife. All right, let's see what we have here. All right. All right, that's enough hand sanding for today. Got a couple of nice spots. We can do a Rockwell hardness test on this. 61.5. Well, we're happy with the heat treat. Now we're going to paint this all up with layout fluid so we can scribe what we need to do on this blade. It is a double-edged little dagger blade. Somebody's going to say that I'm not saying dagger correctly, but you know what? I don't care. Grinding double-edged blades is always a bit challenging. You have to keep the center line even and straight and equal on both sides. This one was even a little bit more challenging in some ways because you don't have that longer length of blade to stabilize things. Bit of 304 stainless steel, and now let's drill a hole. Having fit the guard to the tang of our knife using a combination of drilling, dremeling, and filing, it's now time to grind or shape the form of the guard. I'm using a template, and this is supposed to fit up against a ricasso, but we're using it nonetheless. It's going to work fine, making both sides of the guard the same. I'm using 2 pieces of 3/8 inch thick chili pepper colored canvas micarta for the handle. So we've got a slot that the tang fits into nicely without binding up. We need to be able to get that in and out before the epoxy fully cures on this 2-piece handle. But this is a pretty slick way to do it, especially if you have a milling machine, which I don't, but I may have to use this on some future projects as well. Once the epoxy is cured and we have one solid piece for the handle, we need to fit the front of the handle to the guard so that there's no gaps and it mates up nicely with that. The front of the handle has been fit to the guard and we just need to shape it. We're getting very close to be able to finish this project. So I need to put a final edge on the blade, and I start by using a 120 grit belt and just putting the initial bevel on, and then I'll go to my diamond plate stones and make it nice and sharp. I initially thought I wanted a particular hourglass type of shape on this handle, so I started by using the 10-inch round wheel. And then I realized that's not quite what I wanted, and I switched over to the flat platen and made a nice tapered handle style that's going to be nice and secure, and I really like how that turned out. Alright guys, the epoxy is cured on this unique little knife, this tool. I'll show you pictures of it in just a second here, but I appreciate you watching, and we will see you on the next video.